Hmm. Are plants and rocks living things? What are colors? And why do we see them? How can we fight antibiotic resistance? I'm not a scientist. I can't answer these questions, and I'm definitely not smart enough to figure it out. False! Science is easy-ish. You just have to learn how it's done first. What's that? You don't think you know how to do science? Well, why didn't you say so? Come on, let's go find out. Alright, before we start talking about how we do science, maybe we should first cover what is science, and maybe more importantly, what is it not? Science is a continuous process used to explain the natural world around us in a testable and repeatable manner. Say what? I said science is a continuous process used to explain the natural world around us in a testable and repeatable manner. Duh. Right. So what does that mean? How about we break it down a little bit? For starters, in order for it to be considered science, you have to be able to test your question. We call these tests experiments. Not only does good science use experiments, but these experiments have to be repeatable. By repeatable, this means that someone else has to run the same exact experiment over and over again and be able to find the same answer that you found every single time. If the results of an experiment can't be repeated, then we call that bad science. Now this is where some confusion can come in from the pseudosciences or the fake science. Now many of these practices claim to use a scientific method, but by definition, science can only explain the natural world. So what this means is that supernatural and opinion-based things simply can't be studied by true science. It's not that we don't want to, it's just scientifically impossible to ever explain something supernatural, such as the existence of God, or even the beauty behind art. Instead, scientists are left to study the boring stuff, such as curing diseases, flying through space, and generally understanding how the universe works. Okay, so we've established that science uses experiments, it's repeatable, and it only studies nature. But there's one more part of our definition that we're still missing. Science is also a process, and a continuous one at that. I like to think of science kind of like a never-ending story. As our technology and understanding continues to advance, we continue to add new information to our explanations. These explanations are what scientists call hypotheses. The new information we get comes from running experiments. In some cases, experiments support explanations we already have. Oh, gravity still works. But other times, an experiment can challenge a hypothesis. What the heck? Who broke gravity? When this happens, it forces scientists to run more experiments to figure out what's wrong with their hypothesis and how they can make a better explanation. So in this way, science is a continuous process because we're constantly testing our hypotheses to make sure that we have the strongest and most accurate explanations possible. Perhaps more artfully put, science is evidence-based storytelling. It tells the story of the natural world around us by testing every possible story until it finds one that is repeatedly true. Now, when an explanation or a hypothesis is repeatedly shown to work over many years and thousands of tests, we upgrade it to a more trusted word. That's right, it's called a theory. Now, this isn't a theory like what Uncle Ernie comes up with at the family picnic.
Hey, I have a theory on why Oreos taste so good before bed, yeah.
That's not a theory, Uncle Ernie. That's just an idea. You tell him. Anyway, a true theory is a highly tested, highly proven explanation of something that has withstood the test of time. In science, a theory is the closest possible thing you can find to a true fact on this planet outside the world of math. Math, on the other hand, deals with facts. Because so far as I can tell, no matter where you go, 1 + 1 always equals 2. Okay, alright, cool. So what was science again? Got it? Good. Now that we've actually explained what science is, how about we go and check out how it's really done? Science can happen at many different levels. From asking questions in your kitchen, hey, why does yeast make bread rise? To making black holes in Switzerland. You sure this is safe? But no matter what level of science you're doing, all good science follows the same process. I like to call it the scientific cycle of science. Excuse me, Mr. Kennan? Yes, Kennan without a lab coat? My teacher taught me that it's called the scientific method. Well, your teacher was wrong. Not really. In fact, many people refer to it as the scientific method, but I bet when you learned it, it looked a little something like this. Now, while that may work for basic science and even solving everyday problems, in the professional realm of science, it looks a little something more like this. Either way that you look at it, there are 4 main steps to the scientific method that you should remember. Now, the beauty about science is that you can literally start from anywhere within here and continue on with the scientific process. But I personally like to start with an observation. For example, while cleaning with bleach, I happen to notice that some colors fade quicker than others. Aha! I just made an observation. I just did 1/4 of a science. Yes! But who knows? The doctors do tell me that I need glasses. So maybe I was just imagining this. Well, I could just let it go. Or we could science the crap out of this. Let's go! So we had our observation. Some colors fade faster in bleach than others. The next step was to get to our hypothesis. Now, a hypothesis is an educated explanation. But I'm not educated on the topic of bleach, so this called for some research. Now, I call this looking stuff up, but a real scientist might call it background or preliminary research. Now, what I'd found was that other people had asked the same question as me, and they'd found that yellow seemed to fade faster than blue in bleach. Interesting. Very interesting. But what if they're wrong? I mean, this is the internet. I need to find out for myself. Alright, well, now that I'm educated from the internet, it's time to sit down and make my predictions. I hypothesize. Remember, a hypothesis is an educated prediction or explanation. I hypothesize that if I add the same amount of bleach to yellow and blue mixtures, the yellow will fade faster. And if I want to get real crazy with it, since I know yellow and blue make green, I would hypothesize that if I add bleach to green, the yellow will fade faster, turning the green to blue. Yeah, that's my predictions. Huzzah! Now I've made an observation and made an educated hypothesis. I'm halfway through the science. Let's go finish it. All right, so we've made our observation and we've made a hypothesis. Now it's time for the most fun and the most difficult part of being a scientist: experiments. It's fun because this is where we get to see the cool stuff happen. But it's also work because any good scientist always takes notes. All right, so for our first experiment, we're going to see if yellow food coloring fades faster than blue when bleach is added. Now, like any good scientist, we also have a control in the middle, which is just water, to keep an eye out that nothing wonky is going on with our bleach. All right, here's our yellow. And the bleach is in. Mix it up a bit, and let's count. 4 Mississippi, 5 Mississippi. And look at that. Right before our eyes, it's changing into a clear mixture. Now let's check out the blue. Well, here we are at 30 Mississippi, and nothing seems to be happening. And here's our final product. Our yellow is pretty faded. Nothing happened to our control, and our blue still looks pretty much the same too. Now, as a good scientist, I should probably run this experiment at least 3 times. But for the sake of time, I'm going to go ahead and jump to the next one. Now, our first set of experiments showed us that yellow food coloring appears to fade faster in bleach than blue food coloring. So we're going to use that information to make a prediction. Since green is a secondary color made from mixing yellow and blue, what do you think will happen when we add bleach to this mixture? My prediction is that the yellow will fade faster, leaving only a blue color left in the flask. Let's see if we're right. Alright, that was pretty cool. Let's try it one more time. Oh my gosh! Oh, is it magic? No! It's science, and that's what makes it awesome. And now that we've run our experiments, the last step is to analyze our data and draw our conclusions. So our two experiments showed us that yellow does indeed fade much quicker than blue, which leads us to conclude that I'm not crazy, and my bleach is indeed fading some colors faster than others. And we found this all out with the power of science. Whoop whoop! I did a science! I did a science! I did a science! I did it, Mom! I did it! Well, hopefully you enjoyed this episode, and if not, I hope you at least learned that science isn't some willy-nilly magic, but rather a well-researched process that gives us the best possible answer. Science isn't perfect, but it's still the best tool that we have for finding good, valid information. Furthermore, I want to encourage you to go out and science on your own. Whether you're just asking questions and researching answers, or doing little experiments on your own, get out there and do it. Have fun, enjoy, learn something new. And most importantly, keep feeding that curiosity, because those little questions and projects of today can turn into the big answers of tomorrow. And with that, I want to thank all of you for sticking through and watching this 5th and final Snapisode of my mini-series, Science with Kenan. If you missed any episodes or want to rewatch one or share one with a friend, feel free to check them out on my Facebook page. And please, please, please let me know what you think. About this episode, about the series, anything and everything helps. With any luck, I'll be seeing you back on YouTube in May. Until then, as always, stay classy, Snapchat.